Comparison of 2 daily glucose energy. Between October 5 and October 6, 2025. Number 1383, October 7, 2025. Gerald C. EclaireMD Foundation. Category: Diabetes. Mission statement: I write these medical papers not for fame or recognition, since I have already lived a long and successful life, though not always a healthy one. My purpose now is to share what I have learned about health, disease, and medicine, so that others can better understand their own conditions, prevent illness, and live longer, healthier lives. Abstract: I applied the same linear glucose energy method to October 5, 2025 and compared it with my October 6, 2025 results. Both days shared a similar average glucose level, 115 mg per deciliter on October 5, 2025, and 113 mg per deciliter on October 6, 2025. If I were to rely only on these two average glucose values, e.g., they would lead to nearly identical hemoglobin A1C readings. However, their energy distribution patterns are vastly different, revealing that daily averages alone cannot capture the true metabolic stress or vascular impact caused by glucose fluctuations. But, with the baseline fixed at 140 mg per deciliter, the energy distribution on October 5, 2025 was 0.00% hypo, 97.60% normal, and 2.40% hyper. On October 6, 2025 it was 0.00% hypo, 73.22% normal, and 26.78% hyper, respectively. Their linear glucose energy contribution shares were very different, proving that waveform shape and time spent above 140 mg per deciliter drive the daily metabolic load more than a simple daily mean. This side-by-side comparison demonstrates why an energy view of glucose offers more actionable guidance than averages alone. Methods: I kept all settings identical to paper number 1382. I integrated 96 glucose readings per day, each 15 minutes apart, normalized by 140 mg per deciliter. I summed areas in 3 zones: below 0.5, 70 mg per deciliter, 0.5 to 1.0, 140 mg per deciliter, and at or above 1.0, corresponding to real glucose readings of less than 70, 70 to 140, and at or above 140 mg per deciliter. I did not alter any baselines, weights, or formulas. Results: October 5, 2025. Hypoglycemia energy share, 0.0%. Normal range energy share, 97.6%. Hyperglycemia energy share, 2.4%. Libre average glucose, 115.22 mg per deciliter. Minute and max, 90 and 148 mg per deciliter post-dinner. Observed waveform: long valley around mid-morning near 90 mg per deciliter, 2 modest peaks, with a short crest just above 140 mg per deciliter, brief duration. October 6, 2025. Hypoglycemia energy share, 0.0%. Normal range energy share, 73.2%. Hyperglycemia energy share, 26.8%. Average glucose, about 113 mg per deciliter. Minute and max, 80 and 235 mg/dl post-lunch. Observed waveform: 2 large spikes, with longer time above 140 mg/dl, clearly broader crests. Direct comparison and interpretation. 1. Energy share. October 5, 2025 concentrated 97.60% of energy inside 70 to 140 mg per deciliter, with only 2.40% above 140. This means the body spent almost the entire day in a metabolically balanced zone. October 6, 2025 shifted over a quarter of total daily energy into the hyper zone, 26.78%. Even with a similar daily mean, this extra time at higher amplitude contributed disproportionately to total daily load. 2. Spike height versus duration. October 5, 2025 had a short, low crest barely above 140 mg per deciliter. The limited duration kept hyper energy small. October 6, 2025 had taller spikes, including a peak near 235 mg/dl, and broader crests that stayed above 140 longer. Height plus duration of glucose wave explains the 11 times larger hyper share on October 6 versus October 5, 26.78% versus 2.40%. 3. Physiological meaning. October 5, 2025 is a stability day. Post-meal rises existed but were modest and short. Oxidative and endothelial stress from hyperglycemia was likely limited. October 6, 2025 is a spike-heavy day. The extended periods above 140 mg per deciliter likely increased inflammatory and vascular stress. This is exactly what daily energy aims to capture in a way that a single mean cannot. 4. Operational guidance. The contrast shows that shaving down the height of peaks and compressing the time above 140 produces a large energy benefit. even if the daily average sits near the same value. In practice, this means tightening post-meal behavior, smaller portions, earlier walks, 1 hour after the first bite of meal, and avoiding late day stacking of carbs that can synchronize into a larger second spike. Significant statement. This head-to-head comparison answers a practical question I face every day. When 2 days share a similar average, which one truly burdens my body more? The energy shares reveal the answer immediately. On October 5, 2025, my day was metabolically calm. On October 6, 2025, my health system worked harder due to higher and longer excursions, even though the mean level seems similar. Clinical note: for tracking and coaching, I prefer to watch two numbers side by side: percent energy in normal range and percent energy in hyper range. If I keep hyper under about 10% while holding the mean steady, I can expect a lower cumulative metabolic load over weeks and months. Conclusion: on October 5, 2025, my glucose energy remained almost entirely inside the normal zone, with only a short and shallow excursion above 140 mg per deciliter. On October 6, 2025, taller and wider crests shifted over 1/4 of the day's energy into the hyper zone. This simple comparison, using one fixed normalization and identical integration rules, demonstrates why an energy-based view provides a far better daily guide than relying on a single average value, which is still used by the majority of today's clinicians. Disclaimer: this content is for educational reference only and not medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered, edited, or republished as your own. All intellectual property rights and copyrights for this article and its related materials belong to the author, Gerald C.